Okay, so I'm going to go through this question, which was in the past paper in, yes, Ms. Tipa, it is being recorded. I will provide the recording later this evening once I finish this revision. Okay, so this question asked about the decision to either make use of a car or a bus to travel 1,000 kilometers to Bloemfontein. So I thought this was quite a nice past paper question because it deals with the difference between costs that should be taken into account when you make a decision and costs that can be ignored when you make a decision. So the question says, you and 3 friends want to go on a 1,000 kilometer trip to Bloemfontein. Except for the cost, you are indifferent between driving and taking the bus. In other words, the benefits of taking your car and taking the bus is identical. So what that implies is that the only thing that we're having to compare in this example are the costs of doing these two things. So if it turns out that the cost of taking the bus is more expensive than the car, then we would take the car. And vice versa, if the cost of taking the bus was less than taking the car. So keeping the benefits the same, just comparing costs. The bus fare is 825 Rand per person. You call the AA, so the Automobile Association of South Africa, for an estimate of the cost to drive your car. The AA tells you that for your make of car, a typical 10,000 kilometer driving year involves the following costs. So if you had to drive your car for 10,000 kilometers this year, you would have to pay insurance of 16,650, interest of 22,500, fuel and oil of 19,500, and maintenance of 7,350. Okay. Will you take the bus or go with your car? Show your calculations. So the trick to this question is identifying the costs that you would nonetheless have to pay, whether you took the bus or you took the car. So that is essentially, okay, someone on the chat, or someone is saying, does anyone know when the class will start, or is my Teams just glitching? Okay, I see that person is that person is in the Saturday Teams link. I think that's the issue. Okay, so it's a separate meeting link for today. If anyone is able to on the WhatsApp groups, just say that they need to use the link that was posted on EMS Learn, not the same meeting link as last time. So I just saw that message come through. So they're going to end up being in the wrong meeting. So if anyone's able to do that for me, that would be great. Okay, so if we look at this question, whether we drive the car or not, we're going to have to pay insurance and we're going to have to pay interest. So these two costs here are costs that have to be paid whether the car is driven or not driven. The only costs that change when you choose to drive or not drive your car are these costs over here. So essentially, these are the only costs that we need to take into account when making this decision. So if this is the cost of driving for 10,000 kilometers, so these are costs associated with a 10,000 kilometer driving year, that would imply that 10,000 kilometers comes with a varying cost of 26,850. Everyone understand why it is I'm saying this? Okay, so these are the only costs that are associated with actually using the car to drive. Interest and insurance you pay nonetheless. So if this represents the costs of actually driving the car for 10,000 kilometers, so the costs that actually vary with how much you drive your car, then what that means is that 1,000 kilometers would be associated with 2,685 Rand. So all I'm doing is I'm taking this number and I'm dividing it by 10 to get the 2,685. There are 4 people involved. So it's you and 3 friends. In other words, if you had to use your car to drive these 1,000 kilometers, it would cost 2,685 Rand divided by 4 per person. And so that would imply that the cost per person is going to be 600 plus 285 divided by 4 is 71. So it's going to be 671 Rand and 25 cents. So I'm just going to double check that. 2,685 divided by 4 is 671.25. So this is the per person cost of driving. The bus fare is 825 Rand per person. So the cost per person of the bus is 825 Rand. And so what we can conclude using these values is that they should choose to go with the car, because the car ends up costing less per individual than the bus would cost. Does this question make sense? You can just give me some thumbs up if you're happy with this answer. I notice, okay, great. Thanks for the thumbs up. So I noticed that my video is having a little bit of an issue with timing. And I think it is just because of, similar to the last meeting, we were using quite a lot of memory on my computer for running this video at the same time as Teams. And there are quite a lot of you in the Teams meeting. So yeah, just be patient with the video. It may get better. I see that somebody has their hand up. If you do have your hand up, make sure you ask your question in the chat. Otherwise, if your hand up is meant to imply that everything is good, then just put your hand down, because as long as your hand is up, I'm going to assume that there is a question. So it is, okay, thanks. The hand is down now. Okay, so I'm going to skip forward from this, and I'm going to talk a little bit about a kinked budget constraint, because this kind of came after this work on opportunity cost and sunk cost and all the stuff we did in the last revision, which had to do with market equilibrium. So I'm just going to talk very briefly about kinked budget constraints. So I'm going to go through the logic of how these come about, and draw a few examples of them for you. Okay, so I see a question in the chat. Hi there. If you calculated both values to the total for all 4 people for bus and car instead of per person, is that still going to get the marks? Yes, that would be fine. I suppose, you know, in this case, we could think about the decision at the margin being the decision for 4 people to go to Bloemfontein. So in this case, whether you leave it as a total for 4 people or you make it an average, it doesn't change the answer. I think the time when it would be important to divide by the number of people is if there were different numbers of people involved in the 2 questions. And so we wanted to know something about the average cost. But in this case, if you had left it as a total, it would have been fine, since there are identical numbers of people involved in the 2 questions, or in the 2 options. Let me put it that way. Okay, so a kinked budget constraint. So the example that we had in class was the cost of electricity. So the decision about how much electricity to consume. So I'm going to start with the example where any amounts of kilowatt hour consumed up to 1,000 kilowatt hours is going to cost 10 cents per kilowatt hour. So any unit that is used up until 1,000 kilowatt hours costs 10 cents per unit. And then any units above that 1,000, let's say it's going to be cheaper. It's going to be 5 cents per kilowatt hour. So what we have in this example is a price that is getting cheaper the more of the service or the good that you are using. So how we would represent this in a graph is we would have electricity, so our power usage, on the x-axis. So this is measured in kilowatt hours. And then on the y-axis, we have the composite good, which essentially represents all other goods that could be consumed other than electricity. We typically say that the price of the composite good, which we represent by y, is 1 money unit. So in this case, I'm going to say that it is €1. Okay, hopefully my video unfreezes so that you can see the picture. Great. Okay, so let's think about how the budget constraint would look. Let's say this consumer has an income of €400. What that would imply is that if the consumer consumes absolutely no electricity, then they would have €400 remaining to consume anything else. The composite good, we typically measure either in units, which would be how many €1 units could you buy, or we could represent the consumption of the composite good as a total money amount. So in this case, I'm just going to say that we're going to measure this by units. So we're going to say, how many units of Y could I consume if each unit of Y costs €1? So if I'm buying €1 units of Y with my €400 of income, at most, I could consume 400 units of Y. So this point here represents my maximum consumption of the composite good if I consumed absolutely no electricity, the good on the x-axis. What we would typically do is we would say, okay, but then how many units of electricity, how many of the thing on the x-axis could I consume at most with all my income? And we would use that to get our x-intercept. In this case, we can't do that. And the reason why is because the price of x, the price of the good on the x-axis, is not constant. And so we can't represent our budget constraints by a straight line, because a straight linear budget constraint represents a constant relative price between these two goods. And we can see that because the price of X is changing, that must mean that the budget constraints can't have a constant slope. Okay. So we have to reason through this in steps. So what I would do is I would say, okay, anything between 0 and 1,000 costs this much per unit. So I know that the relative price between electricity and the composite good is going to be constant up to this amount of 1,000 kilowatts. So the first point I'm going to plot is I'm going to say, okay, how much would exactly 1,000 kilowatt hours cost me? So if my decision was to consume on the dot 1,000 kilowatt hours, it's going to cost me 1,000 times 10 cents, which is going to be €100. So if X is equal to 1,000, then it means I'm spending €100 on X. So by X, I mean electricity, which is on the X-axis. That leaves me with €300 for everything else, because to be on my budget constraints, I need to be spending all my income. And so if I have 400 euros available to me and I'm only spending 100 euros on electricity, that leaves me with 300 euros for everything else. So the consumption bundle that I can represent on my budget constraints would be one where I have 1,000 units of electricity and 300 units of Y. So that represents another point on my budget constraints. And I can connect these two points, these two consumption bundles, with a straight line, because I know that the prices of these two products are constant between these 2 points. So when I'm consuming no electricity and 400 units of Y, or 1,000 units of electricity and 300 units of Y, the relative price of these two products between those 2 points is constant. I'm paying 10 cents for electricity and €1 for the composite good. So the slope of the budget constraint between those 2 points is going to be the price of X, electricity, over the price of Y, the composite good. So it's going to be minus 0.1. It's going to be 10 cents over €1. And the slope is going to be negative because this is a negatively or downwardly sloped line. So that's how my budget constraint looks like between 0 units of electricity and 1,000 units of electricity. But then once I go past 1,000 units of electricity, that is when the price of electricity now changes. Okay, I'm just going to quickly escape out of this video, and I'm going to see if I can close any other programs that might be taking up too much memory right now, because the freezing is getting quite bad. Okay, so I'm just going to quickly close a few other programs. Let's see if this helps. Okay. Hopefully this is a little bit better, but it looks like it still might be frozen a bit. Okay, so once we go past 1,000 units of electricity, now our price per kilowatt hour becomes 5 cents. So that implies that every single unit beyond this point is going to have the same price. Every single unit of Y still has the same price. In other words, that's going to mean that our budget constraint for the remainder of our electricity usage is going to have a constant slope. But that slope is now going to be represented by the relative price of electricity beyond 1,000 units, which is going to be 5 cents per £1. So it's going to be 0.05. So that tells me that I can now actually work out my x-intercept. I can say, well, every unit beyond 1,000 is going to cost me the same amount, no matter the units I'm using. And so beyond 1,000 units of electricity, beyond 1,000 kilowatt hours, I still have 300 euros to play with. Okay, so up until 1,000 units of electricity, I'm spending 100 euros. I can then spend a further 300 euros on electricity at maximum, and those 300 euros will afford me 6,000 units of electricity. So I get that by taking 300 divided by 5 cents, and that gives me 6,000. So that tells me that my x-intercept is going to be 7,000. It's going to be the 1,000 units that I bought at 10 cents and cost me 100 euros. And then the remaining 300 euros is going to buy me 6,000 kilowatts more. So my budget constraint for the rest of the time, and I could have pushed that 7,000 out a bit more just to make this more clear, but essentially it's going to have a different slope. There's going to be a kink here at 1,300. If I just draw it very roughly next to here, just to make it more obvious, it would look something like this. It would have quite a severe kink at the point where the price of electricity changes. So this type of kinked budget constraint represents a product on the x-axis that starts off having a higher price. So I don't mean higher than y, I just mean the price of x is higher when the budget constraint is steeper. And on then this range of the budget constraints, we are now facing a lower price of x. So the kink is just representing how the price of x is changing, given the amount that we consume. Somebody on the chat is asking, why is the slope px over py and not py over px? Okay, so the reason why the slope is equal to minus px over py is because if I was calculating the slope of a line, I would find it as the change in y over the change in x. Okay, so that's the conventional way that we look at a slope. If I want to remain on my budget constraints, so remaining on the budget constraints implies that I spend the same amounts. So if I'm moving from one point on the budget constraint to another point on the budget constraint, what that means is that however much more I spend on X, in other words, my change in X, so how much more I consume of X times the price of X must be equal to the price of Y times the change in Y. And we know that that change in Y is going to be negative, because if we're moving along a budget constraint trying to keep our total expenditure the same, it means that we are increasing our consumption of X and we are having to sacrifice some consumption of Y in order to keep our spending exactly the same. If I rearrange this so that I have change in Y over change in X on the one side, which is the slope, that means I take change in X to this side and I take the minus py to this side. And so I get minus px over py. So basically what I've proven here is that the change in Y of the change in X, which is our conventional way of calculating the slope, is identical to taking minus the price of X over the price of Y. The other way that you can think about this intuitively is to understand that if I want more X, I'm going to have to take what I spent on Y and reassign it to my consumption of X. And how much I'm giving up of Y is then going to afford me some amount of X. So the price X over price Y is equal to the change in Y of the change in X. Don't think that a slope always has to have Y over X. It depends on what units are you working with. If it's the rise over run, by all means, change in Y over change in X. But that is equivalent to the relative price of the product on the x-axis. Does that make sense, Mr. Prague? I think it was you who asked the question. Okay, so that is why it's px over py. So this is an example of a kinked budget constraint where the price of X starts off or at least starts off higher and then becomes lower. We can now just reason very quickly through some other shapes. So let's say we have some product X and some product Y. And let's say that the price of X is the same no matter how much X I consume. In other words, the price of X is constant over all quantities of X. But now let's say that the price of Y falls when I consume more of it. In other words, if I'm choosing to purchase quite a lot of Y, I'm able to benefit from a lower price. Okay, now this is where you have to think very carefully, and this is why it's really good you asked the question that you did, Mr. Prague, because the slope of the budget constraints is represented by minus the price X over the price of Y. Okay, so what we're saying is that when Y is low, so when I'm consuming not so much Y, the price of Y is very large. Okay, so the price of Y is higher, the less Y I consume. And that would mean that this value, price Y in the denominator, is larger. And so it would make the relative price of X smaller. So it would make the slope of our budget constraint smaller. But if I consume more Y, the price of Y goes down, it gets cheaper. And so that would mean the denominator is a smaller value. And so the slope would be bigger. So I should expect to see a budget constraint that at higher values of Y has a steeper slope, and at lower values of Y has a flatter slope. In other words, this budget constraint is going to look exactly like the one we just did. So for larger amounts of Y, the price of Y is small, which makes the slope bigger. But at smaller amounts of Y, the price of Y is larger, which makes the slope smaller. And so the budget constraint gets flatter. Okay, what if, on the other hand, the price of X is always the same, but the price of Y increases when I consume more of it? So it gets more expensive the more I consume of it. In this case, my budget constraint is going to start off flatter and then get steeper. So if you have a budget constraint that is kinked in such a way where it starts off flatter and then it becomes steeper, what that means is that the relative price of X starts off low and then becomes larger. And the relative price of X can be small for two reasons. The relative price of X can be small if Y has a higher price or if X has a lower price. And the relative price of X can be larger for two reasons. Either the price of X is high or the price of Y is small. So you can see that the slopes of these kinked budget constraints depend on prices changing, and that could be the price of either Y or X. It doesn't have to be the price of X that is changing every time in order to get a kinked budget line, because the slope of this budget constraint is a relative price. It is affected by both the price of X and the price of Y. So be very careful when you look at a budget constraint and you interpret which price is changing. It is not guaranteed that it is always X. Okay. Does that make sense? Okay, I see your heart. I'm going to take that as that makes a lot of sense. Great. Okay, so kinked budget lines are simply just scenarios in which one of the prices are changing. And then some of the other budget constraints that we saw that had kinked, like a kinked shape, was the food voucher, where it started off being horizontal and then it became downward sloping. What does it mean if a budget constraint is horizontal? like this, it means X is free. There's no price of X. And then all of a sudden now we're having to face some price of X and some price of Y, which is why we get a slope of some kind. So when it's horizontal like this, X is free. If, on the other hand, and this is what we saw with the school voucher, it started off horizontal and then it went vertical and then it went down. For this first part of the budget constraint where it starts off horizontal, X is free. For this part, what we're essentially saying is that we're having to pay and we're not getting any more amount of X for it. So in the case of the school voucher, that first movement here from 0 to 1 was getting 1 unit of public education. The movement from the horizontal line vertically down is now saying you still have only 1 unit of education, but now that 1 unit of public education is being converted into 1 unit of private education. And that's why you face this vertical drop, because when you convert that 1 unit of public education into 1 unit of private education, you are having to pay an extra amount for that private education. And you're not getting any more education for it. You're simply getting private education in the place of public education. Okay, so that's why it has that shape there. So we're having to pay more, but our X isn't increasing. And that's actually very similar to the budget constraint we saw with electricity. When we did the example with electricity where you are paying 5 cents if you use up to 1,000 units. So just going to redraw that quickly. So let's say, hopefully it unfreezes so that you can start to see what I'm drawing. Yes, I will upload the sheet afterwards. The video is very laggy. It is struggling today. Okay, so let's say up to 1,000 units, the price is 5 cents per kilowatt hour. And then if you consume, will the recording be laggy? Yes, this is what is recording, unfortunately. It's just, yeah, oh no, is definitely the answer. I did not realize that the video would be struggling so much today. But hopefully the combination of the video and the pages that have my drawings, if you can use my voice, the audio alongside the pages, it will hopefully be useful, even if the video is lagging quite a bit. Okay, so let's say up to from 0 to 1,000, it's 5 cents per kilowatt hour. But then if you go anywhere above 1,000 kilowatt hours, you have to pay 10 cents for every single unit you've used. In other words, if you're using only 1,100 kilowatt hours, so only 100 kilowatt hours above the threshold of 1,000, you have to pay 10 cents for all 1,100. If you had chosen to consume only 100 fewer kilowatt hours, so you'd capped yourself at 1,000, you would have only had to pay 5 cents per kilowatt hour. So what that implies is that in the beginning of your electricity consumption, you would face a cheaper price of X, and so your budget constraint would be flatter to begin with because the relative price of X is now smaller because the price of X is only 5 cents and the price of Y is €1. Then we suddenly go over this threshold of 1,000. And if we go over this threshold of 1,000, it means that all of the units we had consumed up until that point suddenly are double the price. And that is why we experience this almost vertical, well, quite literally a vertical drop in our consumption ability. Up till this point, we were only spending 50 euros on electricity, which is why we had 350 left over to spend on everything else, on our composite good. We go just above 1,000 kilowatt hours, and all the units we've consumed up until that point suddenly cost 10 cents each, which means we lose 50 pounds or 50 euros, sorry, of income. It's like it just vanishes because all of a sudden we're now having to go and back pay for the 1,000 that we've already consumed. And then beyond that point, our budget constraint becomes steeper because now we face the price of 10 cents per kilowatt hour. So the slope up until 1,000 kilowatt hours is minus 0.05, 5 cents divided by 1 euro. If we go on this top part of the budget constraints, from zero consumption of electricity up to 1,000 units, the slope is going to be minus 0.05. And that's because up until that point, if you could stick to that limit, the price that you would pay per unit of electricity would be 5 cents. If you go just beyond that 1,000 usage, that 1,000 kilowatt hour usage, you now face a price of 10 cents per unit, but that 10 cents has to now be applied to even the first 1,000 units that you consumed. And that's why you experience this loss of consumption possibility of 50 euros. You just all of a sudden had 50 euros, but now just because you went beyond the 1,000 mark, you have to spend another 50 euros for the electricity you already consumed. And then beyond that point, from 1,000 units onwards, the slope then becomes minus 0.10. And that's because beyond 1,000 units, now that higher price of 10 cents per unit kicks in. So we can't have two separate budget lines here because this is one consumer having to choose how to spend their income on electricity and the composite good. So we need to be able to represent these two prices, but then also this discontinuity that you would experience if you had to suddenly consume more than 1,000 kilowatt hours. So these kinked budget constraints and these discontinuities and these horizontal portions and these vertical drops or these vertical portions are all just there to show us how the consumer is going to have to choose to consume. We have to represent their possibilities in a way that we can now bring their preferences into line with those possibilities and find the best choice that they can make. So yes, it looks a bit awkward, but it's an extremely powerful tool to be able to represent all of this nuance of price changes in one picture. So yes, I understand it looks confusing, but if you break it down, it makes quite simple logical sense. Okay, so I'm going to move away from budget constraints and I'm going to go to elasticity and consumer surplus, because these are the last parts of the course that will be tested on Wednesday. And so I wanted to be sure to do some of this in the revision. What I'm going to do is I'm just going to quickly quit my camera. Okay, it's still lagging a bit, but maybe it cooperates with us. Okay, so this is a question from the A1 in 2023, and it's asking us to calculate the price elasticity of the demand at a price of 100 if the demand function is given by the following equation. QD equals 1,125 minus 10 price. Okay, so what we need to have in order to do this question is we need to have our formula for price elasticity of demand. And that formula, we use the point slope method in order to calculate elasticity. So the point slope method is equal to 1 over the slope of the demand curve times the price quantity combination on the demand curve. So this is why we call it the point slope method. It's because we are using the slope and a point on the demand curve, a point which simply represents a price quantity combination. So they've given us a demand function, not a demand curve function. So demand is represented as quantity is a function of price, whereas a demand curve is when we write price as a function of quantity. The reason why I'm telling you this is because it means you actually have one less step to do here in this calculation. Because if we need 1 over the slope of the demand curve, and we don't have the demand curve, we have the demand function, it means that 1 over the slope of the demand curve is the same as the slope of the demand function. Okay, so remember the demand function and the demand curve are reciprocals of each other. So 1 over the slope of demand is minus 10. It is that slope of the demand function. I can also prove to you, if we actually calculate the demand curve from this demand function, that we would also get minus 10 if we used the slope of the demand curve. So let me just do that. So if my quantity is equal to 1125 minus 10 price, what that means is that 10 price equals 1125 minus Q. And then if I divide through by 10, I get price is equal to 1125 over 10 minus 1 over 10 times Q. So this is me just finding my demand curve from my demand function. And here we can see that the slope of the demand curve is minus 1 over 10. And so what is 1 divided by minus 1 over 10? It is minus 10. So when you use the elasticity formula here, this 1 over slope D, or slope of D, this represents 1 over the slope of the demand curve, which is equivalent to the slope of the demand function. Okay, so we actually already have this value. It's minus 10. And then to calculate the price elasticity demand at the price of 100, it means that the price I put in there is going to be 100, and now I just need my quantity. And my quantity is going to be the Q when price is 100. So if I sub in price for 100 into my demand function, I get 1125 minus 10 times 100, which is 1,000. And so I get 125. So I end up having the following answer for my elasticity. It's going to be minus 10 times 100 divided by 125, which is minus 8. And so the answer to this question is, the elasticity value is minus 8. Okay, so you don't have to use the demand curve for an elasticity. You can also use the demand function, because these two functions are exactly related. They are reciprocals of each other. So when you have a demand function, you have all the information that would be contained in a demand curve. And if you have a demand curve, you have all the information that would be contained in a demand function. Okay, Does this make sense? I know the final answer hasn't appeared yet in the video, but hopefully you were able to follow along with me whilst I was talking. So if we have an elasticity value of -8, how would we interpret this? We would say that the elasticity value of -8 in absolute terms is greater than 1. And because the absolute size of our elasticity is greater than 1, this would imply that our demand is currently price elastic. So elasticity at this price of 100 has an elastic demand. Okay, so that's the one elasticity question. I'm going to move on to another elasticity question, if everybody is okay with that. I'm just going to check the chat. No, everything's good. Okay, so let's move on to another elasticity question. So this is an elasticity question from last week's tutorial, and it's the cross price elasticity. So we have 3 different types of elasticities that we talk about in this course. We have price elasticity of demand, which relates the percentage change in the quantity bought of a product to a percentage change in the price of that product. So that's the example we just did. We then have cross price elasticity, which is this example here, that looks at the percentage change in the quantity demanded of one product in response to the percentage change in the price of another product. So this is what we mean by cross price elasticity. What we're saying is that demand is not only determined by the price of that product. Consumers' demand is determined also by income, and that's where the income elasticity comes from. And it is also determined by the prices of related goods. So we choose to consume products together or in place of other things. So when I choose to consume coffee, for example, that decision to consume coffee may be related to the decision to consume milk if I enjoy cappuccinos, for example. And so milk and coffee then become complements. The demand for the one is related to the demand for the other. Substitutes would be something like, let's say, Monster and Red Bull. So let's say that instead of drinking Monster, you could be drinking Red Bull. And so you would see these 2 things as substitutes for each other. And so if the price of one of these products change, it would then change the quantity demanded of the other. Okay, so we have 2 products, X and Y. I was using Z in the formula, but that's because how it's expressed in the textbook. So let me just replace this quickly. So the elasticity or the cross price elasticity of X and Y is equal to the percentage change in the quantity of X over the percentage change in the price of Y. The other way that we write this is we say that this can be written as the change in the quantity of X over the change in the price of Y times the price of Y over the quantity of X. So this is exactly the same formulation as the price elasticity of demand. But now instead of comparing QX and PX, so looking at the quantity and price of the same product, we're looking at the quantities and prices of 2 different products. So what I'm going to do is I'm now going to stub information from here, from the question, into this formula. So in 2023, X cost $3 and 400 units were sold. That same year, Y cost $10 and 200 units were sold. In 2024, X still cost $3, but only 300 units were sold, while Y rose in price to $12 and only 150 units were sold. Now, this question is giving us a lot of distracting information. So we need to be very clear about what values we require from this information in order to calculate our cross-price elasticity. So this is how I would reason through it. I would say, okay, so Cross-price elasticity is looking at how a quantity of one good responds to a price change of another good. In this question, there is only one product whose price is changing, and that is Y. Y went from being $10 to being $12. So that's telling me that the price change is referring to Y. And that's interesting because that's exactly the way that I've written it in the formula. So that was lucky. So the price of Y has changed. And we now need to contrast that price increase in Y with a quantity change in X. So the change in the quantity of X as a response to this price change in Y, X was 400 units sold, and now it is 300 units sold. So that's my quantity change that I'm interested in. So my change in quantity is going to be minus 100. Why is it minus 100? It's because quantity went down. It went from 400 to 300. So it is minus 100. And the change in price is going to be 2, because the price went from 10 to 12. So it went up by 2. And then the price and quantities that I use in the remainder of this formula are always referring to the original price. So the elasticity is always calculated from where we started. So the price Y in the formula is going to be the original price of 10, and the quantity X in the formula is going to be the original 400 units. So I end up with my cross-price elasticity as minus 100 over 2 times 10 over 400. And that gives me times 10 divided by 400 is minus 1.25. So my cross-price elasticity is minus 1.25. How do we interpret it? We interpret the sign that's coming in front of that elasticity value. So we need to judge, is a negative indicating a substitute or is it indicating a complement? So one way that you can reason through this rather than trying to memorize, okay, negative is this and positive is this, is to think about what would cause the amount of X to go up if the price of Y went up. What does this mean about these two products? If Y gets more expensive, why would I now consume less X? And the reason must be because they are complements. If something is getting more expensive, we would choose to consume less of that thing. And by implication, we would choose to consume less of other goods that we consume together with it. And so that's why we end up with a negative cross-price elasticity means that these two products are complements. If we ended up with a positive value, it must mean that they are substitutes, because if something gets more expensive, I would then choose to consume less of that product and more of the substitute. And so a price increase corresponds with a quantity increase. So I always try to reason through the answer rather than relying on memorizing, okay, negative is complement, positive is substitute. It really helps to go through the intuitive reasoning or logic of how these two goods are related. At least you can see the question so that when I talk through the question, you can, see exactly what I'm talking about. So I'm just grateful that the question is at least showing up on the screen, if anything else. So this question tells us that there is an ice cream cone seller on Glamps Bay Beach, and they face a daily demand of the following: Q equals 1,800 minus 15 price. And the price is the price of, P is the price of an ice cream cone, and Q is the number of ice cream cones bought daily. The first part of the question then asks, if the seller sells 300 cones per day, calculate what the price, total revenue, and price elasticity of demand are. So this question is asking us to do several things. We need the price, We need the total revenue and the price elasticity of demand. Whenever I see questions like this, which have multiple things that they're asking for you in the question, what I always do is I just write down all the things I need to calculate, just so you don't miss something. The amount of times I've marked a paper where somebody was asked to calculate quantity, and the way the question was set up, you would get price first, and then students just stop there. Because you think, okay, I have an answer. So just please make sure that you write down everything you need to calculate in a question. So in order to get the price, what we need to do is we need to sub this quantity of 300 into the demand function. So if quantity, which is 300, let me write that out. So if 300 is equal to 1800 minus 15 price. Oh my gosh, the video is amazing right now. Thank goodness. And then we rearrange this. So we have 15 price equals 1800 minus 300. And so then we have 15 price is equal to 1500. And so that means the price is 100. So there's my first answer. Price is 100. How do I then get total revenue? So total revenue is equal to price times quantity. So now I have my price of 100. I was given my quantity of 300. So the total revenue is 30,000. Everyone with me? I'm actually blown away by how good the video has been right now. Ecstatic. Okay, and then the last thing is the price elasticity. So now we just use the formula we saw earlier. It was -1 over the slope of the demand curve times the price over quantity. And as I said earlier, actually we don't need that minus because the slope is negative. I'm running ahead of myself. So as I said earlier, 1 over the slope of the demand curve is the same as the slope of the demand function. And we have the demand function, and the slope is -15. So my elasticity is going to be -15 times, and then my price quantity is exactly what I have, which is 100 over 300. So what I have is the elasticity is -15 times a third, which is -3. So I have my price, I have my total revenue, and I have my elasticity value. Everyone good with this? I can move to the next part of the question. How do we know if you've given us the demand curve or function? Okay, so demand function is always represented as quantity as a function of price. So the demand, how much I demand, the quantity I want, depends on the price that is charged. So that is how demand actually works. I walk into a shop, I look at the price, and then I decide how much I want. Okay. Oh, you're right. It's -5. Thank you. Everyone's screaming in the chat. -5, not -3. Perfect. Yes. -15 times a third is -5. So it should be -5. Thank you for that. Okay, so the demand function is quantity as a function of price. The demand curve, which we also call the inverse demand function, because it is the inverse of the demand function, that is price as a function of quantity. And the reason why the demand curve is price as a function of quantity is because that is how we plot it. We plot it with price on the y-axis and quantity on the x-axis. So that's the difference between the two. But they are essentially the same thing in the sense that they contain identical information. Whatever quantity I get for a value of price here, that is the quantity that would give me that price here. So they are reciprocals of each other, the inverse of each other. Okay, thank you everyone for correcting that mistake. It should be -5. Okay, so now if the seller wants to increase his total revenue, should he increase or decrease his price? Explain your answer. So the elasticity value in absolute terms is 5. So -5 in magnitude in absolute terms is 5, which is greater than 1. That tells me that demand is currently price elastic. So price elastic demand. If you as a seller of a product face price elastic demand and your goal is to increase your total revenue, you should then decrease your price. And the reason why is because if you face elastic demand, it means that the percentage change in quantity will exceed the percentage change in price. So if you decrease your price by even a little bit, your quantity will increase by a proportionally larger amount. So price elastic demand would mean lower your price in order to get greater total revenue. If you have price inelastic demand, then you should increase your price to get greater total revenue, because in that case, your percentage change in quantity is smaller than the percentage change in price. And so even if you increase your price a little bit, it's not going to deter people much in terms of their reduction in quantity demanded. So in this case, people are not as responsive to the price change. And so you can get more revenue even with a price increase. Everyone happy with this question? I can move on to consumer surplus. Okay. So this is from 2024. And the question tells us that the demand function of a firm that is currently selling 6 units, so Q equals 6, is price equals 40 minus 4QD. Now, this, based off of what I've just said, is technically not correct. For this to be correct, it should say the inverse demand function, because this is price as a function of quantity. Sometimes you pick this up in papers. So to be technically correct, it should have said the inverse demand function. So price is equal to 40 minus 4Q. Now it asks us to define the concept consumer surplus and what is the size of consumer surplus in this case. Okay, so consumer surplus represents the difference between the maximum price that a consumer is willing to pay and the price that they actually pay. So consumer surplus represents the benefit that you get over and above the price you face in the market. So you are actually willing to pay more than what the market is charging. And how it's represented graphically, so how this translates into the picture, is if this is the demand curve for the consumer, and let's say this is the demand curve that the firm now faces. So the firm faces the following demand from its consumers. It has a y-intercept of 40, and the slope of this is -4, according to the function of the demand curve. And the market is going to be charging some price. So this firm is going to have a price that is set through the combination of its demand and supply. And so some price is going to be charged. We now find that consumers choose to buy 6 because that's how much they're currently selling. So we could figure out what is the price that must be charged in order for only 6 units to be bought. So we can calculate that using this function here. We would see that price is equal to 40 minus 4 times 6. So the price at the moment must be 40 minus 24, which is 16. So this value here is 16. So the consumer surplus represents the difference between what each of these consumers was willing to pay at most, which is represented by the demand curve. The demand curve tells me that the first person, consumer 1, was willing to pay that much. And so they get consumer surplus from that first unit because they're only having to pay 16. The second person was willing to pay this much, and so they get some consumer surplus from the fact that their willingness to pay exceeded the price they actually paid. And for the third person, the fourth person, the fifth person, and then the sixth person is ending up paying exactly the price that they were willing to pay in this market. So the consumer surplus is that area underneath the demand curve and above the price that is being charged. So the second part of the question that asks, what is the size of consumer surplus in this case? It's going to be the area of that triangle there, which is half times the base, which is 6, times the height, which is 40 minus 16, which is 24. And so the consumer surplus in this case is going to be 3 times 24 is 72. So that is the amount of consumer surplus that is being generated by the fact that consumers are willing to pay more than what the seller is charging them. Everybody happy with this? How to find the consumer surplus? Okay. 6.1.2 then asks us, what is the firm's total revenue if it practices first-degree price discrimination? Okay, now we haven't actually spoken about first-degree price discrimination in class, but I have shown you how it works. So this is how first-degree price discrimination works. Now, if everyone was charged exactly the same price of 16, the total revenue would simply be this area underneath that price multiplied by the quantity. So this green rectangle would be the total revenue if all consumers pay the same price of 16. How first-degree price discrimination works is very similar to the example I did in class where somebody wants to play golf or wants to play tennis at a club, and they're willing to pay a price, and that price, well, they're willing to pay a price that exceeds the price that is charged by the club for every game that is played. So let's say the club charges $10 for a game, and at $10, you want to play 50 games a year. But what we've seen with this demand curve here is that actually you were willing to pay a lot more than $10 for the first game, and the second game, and the third game, and the fourth game. So all of those games, you actually had a higher willingness to pay than what you actually paid because you had a higher marginal utility or a benefit from playing. So the club, what they can then do is they can say, okay, well, you know what? If you want to play tennis here, or if you want to play golf here, you're going to have to pay a membership fee before you even start paying to play. That is capturing the consumer surplus. So when first-degree price discrimination is used by a firm, what they're doing is they're charging every single person their willingness to pay. So if I could say to the first person here, you need to pay me 40. The second person needs to pay me 34. The next person has to pay me 30, and so on and so on and so on. If you could identify every consumer's exact willingness to pay, then you could discriminate according to that willingness. And that means that your total revenue would be that entire area, the triangle, and the rectangle. So that would be total revenue under first-degree price discrimination. Must we learn discriminations for the A1? You don't need to understand it in this case, but how you do need to understand it is the way that we talked about it in class, which was having a two-price strategy. So doing a double pricing. So for example, let's say a consumer of tennis, they face the following demand curve. So this is a single consumer of tennis. They get told that to play a game of tennis, they must pay this price. So if this is the price they have to pay per game, they end up playing so many games of tennis. And so that means they would end up spending this much in total on tennis. They would spend price one for Q1 games. That means they are making consumer surplus over and above what they are spending to play tennis. The club or the place where they're playing tennis can then say, okay, I can actually charge this consumer surplus as a membership fee. So what I can do is I can say to this person, you need to pay me a membership fee. And at most, they could only charge them the amount of this consumer surplus. Because if they charge them more than that consumer surplus, the person wouldn't even join the club. But because this person is getting all this additional value over and above the price they pay to play tennis, the club can convert that consumer surplus into a second price, into the membership fee. So then this person will pay the membership fee and that amount to play tennis. And so in the end, they end up spending this entire area, this entire purple area there. Does that make sense, Ms. Smith? So that's the way we talked about it in class, but it is essentially like first degree price discrimination, because I'm getting all of the consumer surplus, all of the benefit, all of the maximum willingness to pay out of this consumer. And I can charge them a different price than just simply the price to play the game of tennis. I can charge them to play tennis and a membership fee. Is everyone happy with this? So this is how consumer surplus works. Or is there anything else I can explain about this? The other thing I wanted to do that I mentioned at the beginning was just to talk about what we mean by an upward sloping or downward sloping indifference curve, because I got a question in an email and I thought that that was a really good question. So somebody asked me, if you have an indifference curve like this versus an indifference curve that looks like this, why does this one represent more is better, but this one violates the assumption that more is better? So I'm just going to explain that very briefly. Okay, so let's say we have a downward sloping indifference curve like this. Why does this represent more is better? Let's say I'm consuming over here on my indifference curve. So I'm consuming Y1 and X1. And I then decide I want to consume more X, but I want to stay equally satisfied. So if I consume my consumption of X from X1 to X2, and I remain equally satisfied, it means I'm moving along my indifference curve from this point here to this point here. This represents more is better because if I increase my consumption of X, I'm going to get more utility from X. That's what more is better means. So consuming more X means getting more total utility from X. How do I then keep my utility the same by consuming more X? It means I have to consume less Y. So more is better gives us a downward sloping indifference curve, because when I increase my consumption of the one product, that's going to make my utility go up. And so in order to remain on the same indifference curve, to keep my total utility the same from both goods, I have to decrease my consumption of Y. So a downward sloping indifference curve corresponds with more is better. Both of these products give me utility, the more utility, the more I consume of them. Okay, so how does an upward sloping indifference curve violate this? Let's say I start here. I have X1 and Y1, and I decide that I want to consume more X. What I find is that when I consume more X, I can be just as happy when I consume more Y at the same time. In other words, this indifference curve tells me that if I increase X, I don't, or let me say, when I increase X and I increase Y, my utility stays the same. And the reason why the utility stays the same is because one of these products must be giving me disutility. For one of these products, less is better. So when I'm increasing my consumption of X, what I find is that I now have to increase Y at the same time just to keep myself as happy. And if I look at this picture here, the change in Y is a bit larger than the change in X. And that tells me that X must be making me unhappy. And so in order to counter that negative effect on my utility, I need to increase Y to keep myself as happy before. So an upward sloping indifference curve doesn't agree with more is better. An upward sloping indifference curve means that for one of these products, less is better, because in order to make up for any utility I lose from having more of the bad, I need to consume more of the good. Okay, so this type of indifference curve represents more is better for both goods, and this is more typical. Whereas this picture represents a situation in which less is better for one of the goods. Here, more is better is not guaranteed. Okay, so I thought that was a very interesting question because it helps to understand what more is better is about. So that's all I had planned for today. And I actually think someone did ask me to show how you get a market demand from an individual demand. But let me look at the chat. Okay, so Adrian Geert asks, so would one of these goods be a bad? Yes. So in this picture, if you have an upward sloping indifference curve, one of the goods is a bad. Okay, so upward sloping indifference curve implies that more is better is violated. Okay, can you please give the answer of 6.1.2 again? Okay, so this one here. What is the firm's total revenue if it practices first degree price discrimination? So so I actually didn't complete that. Great. So I explained to you how to find it, but I actually didn't calculate it. Okay, so the firm's total revenue, if it practices first degree price discrimination, would be the entire area of the triangle and the rectangle. So the triangle we already calculated is 72. So it would be that 72 plus the area of this rectangle, which is 16, 0 to 16 times 6. So that's going to be 72 plus 96, which is 168. Okay, so the answer was 168. Do we need to learn the tax and tax rebate questions? I didn't cover tax rebates, so no, you do not need to do the tax rebate. I opted to do the school voucher instead as a policy application. With taxation, all you need to know is what was covered in chapter 2 and in tutorial 1. So how to show how a tax affects equilibrium price and quantity, and then how to work out the share of the tax burden. Okay, Mr. Pritchard, it would be impossible for both goods to be inferior. So there is never going to be a question in which both goods are inferior. I can only ask you the income and substitution effect if both are normal, and if one is normal and one is inferior, but they cannot be both inferior because that would be impossible to draw. How will the policy applications be examined in the examination? So the policy applications, essentially the main takeaway from those is in understanding how to interpret the results. So when I covered that in class, my main emphasis was on how do we represent this in a budget constraint? And then when we combine this budget constraint with the preferences of individuals, what solutions do we get? So with the food voucher, for example, what we found is that depending on the preferences of the people involved, a food voucher may be worse than cash, or cash may be equivalent to a food voucher. So what you need to understand there is more about what does the policy mean for the choices that people make, and the school voucher as well. So the school voucher section is not in the A1. Only the food voucher was covered in the work up to the A1. But the main thing is interpreting how people make choices when they are faced with budget constraints that are affected by these kinds of policies, and how preferences give us different outcomes. Okay. I'm not interested in you replicating it, like saying for 10 marks, draw this graph and explain it. That's not what I'm interested in. I'm interested in can you identify how behavior changes under different conditions? I hope that makes sense. Okay, Mr. Pritchard, you meant, yes, if one in normal is one in inferior. Okay, I can definitely do that. So I'm going to use the bread and steak example that I used in the other revision. So let's put steak on the y-axis, and then let's put bread on the x-axis. So bread is my inferior good, and steak is my normal good. And then, okay, let's ask Mr. Pritchard, since he asked for this, which price do you want me to change and in what direction? I'll leave it up to you to tell me which product's price changes and in which direction. Does it go up or does it go down? Either one. Okay, you're making me decide. Okay, let's make steak cheaper. So let's say the price of steak goes down. I did steak up in the last revision. Yeah. So in the other revision video, I did the price of steak going up. So let me do the opposite now. Okay, so let's say we start off with this budget constraint, and the consumer starts off at a best affordable point like this. And they consume so much bread initially, and they consume so much steak initially. So A is the original optimal bundle. Okay, so the original optimal bundle contains B1, S1. Now there is a reduction in the price of steak. And so what that means is that this budget constraint is going to pivot up along the axis for steak. So the budget constraint becomes something like this. So I'm going to call that B2. So the y-intercept doesn't change, but the x-intercept increases because my real income in terms of steak is now greater. Okay, so the budget constraint pivots like this. This is where I pause and I reason through how my graph is meant to look. So I've got my two products, bread and steak, and I'm going to have to represent their substitution effects, their income effects, and those are meant to give me some total effect. The substitution effect has to do with how does this consumer change their consumption of these two goods, holding their utility constant. In other words, how do they remain on the original indifference curve, but the relative attractiveness of these two goods has shifted because of this price change. So how I reason the substitution effect is as follows. At A, the marginal utility from bread over the marginal utility from steak was equal to the price of bread over the price of steak. That is one of the conditions for being in a best affordable point. These things have to be equal, and you need to be on your budget constraints. But now the price of steak has gone down. And that means that this arrangement has changed. The consumer would no longer be optimizing because they face different prices. So how I rearrange this is I say, okay, this is the same as saying that originally the marginal utility of bread over the price of bread was equal to the marginal utility of steak over the price of steak. But now the price of steak has gone down. And that means that at this point in time, this is not the case. The consumer isn't equating their margin utilities per rands anymore. Because steak is now cheaper, it means that whatever additional utility that this consumer could get from spending money on steak exceeds the extra utility they could get from spending more money on bread. So steak is now relatively more attractive. So steak is now relatively more attractive. This consumer would do better by consuming more steak and less bread. So that implies that the substitution effect for bread will be negative and the substitution effect for steak will be positive. I would substitute towards steak away from bread. And how I represent this in my picture is I now say, okay, the new budget constraint B2 represents the prices I now face in the market. And so I need to find where these prices are equal to my marginal rates of substitution. So I find where does the slope of the budget constraint give me the same MRS on my indifference curve. And so I then draw in my imaginary budget constraints. This budget constraint, the dashed one there, is like me moving back onto my original indifference curve because I want to keep my utility the same. But I now realize that facing new prices, I'm going to have to change the combination of steak and bread on this original indifference curve. So I end up at a point like that. So this point C, that is my substitution effect. When I go from A to C, I am substituting away from bread. And you can see that negative effect there. And I'm substituting towards steak. And you can see the positive effect there. So that is the substitution effect. So how we find the income effect now is we consider the fact that this consumer used to have a feasible set represented by the area underneath the old budget constraints. But now, faced with a cheaper price of steak, what is feasible for them has actually increased. So the fact that the feasible set, what is possible for this consumer, is increased, tells us that they now have greater purchasing power. So the price decrease has led to greater purchasing power. And so our income effect, we interpret as how does the change in this person's purchasing power now come through in their consumption choices. And when you have greater purchasing power, what you would end up doing is consuming less inferior goods and more normal goods. So that is how we define inferior and normal goods. Inferior goods are things that when we feel relatively wealthier, either because prices have gone down or because we have greater incomes, we demand more of fewer of the inferior goods. But if we have greater purchasing power because prices have gone down or our incomes have gone up, we would demand more normal goods. So we buy more normal goods, fewer inferior goods. So the income effect for bread would be negative because we are wealthier now. We're too good for bread. And we would buy more steak. Now we want all the steak because we have the purchasing power that makes it possible to consume steak. That tells me that if C is where my substitution effect ended, now my income effect has to pick up from where substitution ended. And so my income effect has to take me even further negative on bread. So the a negative income effect has to be added to my negative substitution effect. And the positive income effect for stake needs to come on top of that substitution effect. So where I choose to draw my new best affordable point has to reflect those income effects. So I just choose a point up there because this would correspond to a negative income effect. The movement from C to D, my new optimal bundle, is my income effect. So this corresponds with a negative income effect. And then here is my positive income effect for stake. So that gives me a total negative effect for bread and a total effect for stake that is positive. So if I had to write this out, I would say that my substitution effect for bread is the difference between B2 and B1. So it would be that difference there. My income effect for bread would be the difference between B2 and B3. So that's my income effect. And then my total effect for bread is going to be those added together. So it's going to be the difference between B3 and B1. For stake, it's the same. So my substitution effect for stake is S2 to S1. My income effect for stake is S3 and S2, and then my total effect is going to be S3 minus S1. Okay, so this is how I would draw out the substitution and income effects, so the full Hicksian decomposition for two products where one is normal and one is inferior. From what I got in the slides, we didn't need to be able to calculate C, but do we have to? So you can calculate C, you can either read it off from the picture. So there was an example that I did in the previous revision where I read the substitution and income effects off of the picture. So you can go and review that revision video. The other way that I could calculate C is using the math, and that I also did in the previous revision. So if you go through the previous revision videos, you will see how you can actually calculate the substitution effect and the income effect using the math.